Hello grade 11s, once again. We are going to continue with our functions, the trig functions from the previous lesson that we had together. We're going to make sure that we revise and then we move on to more parameters. So today we're talking of changing parameters of trigonometric functions, right? But just to recap, you had your parent functions, which is your y equals to sine x, your y equals to cos x, and your y equals to tan x. Sorry, and then we looked at the period as well. When is it going to repeat itself? So it's going to repeat for the y equals to sine x. The graph is going to repeat every after 360 degrees. The y equals to cos x repeats every after 360, and then the y equals to tan x, it's going to repeat every after 180 degrees, right? And then with your amplitude, okay? So now if you check, the amplitude for y equals to sine x is 1, and the amplitude of y equals to cos x is 1 as well, and it's not defined for the y equals to tan x. All right, and then now if you look at your domain, right, given examples, right, the domain is always going to be given in your inequality format or your interval notation, okay? So you can either start from 0 to 360 degrees or negative 360 to 720 and so forth, all right? So for all, the x is going to be represented in your interval or your inequality form. And then your range as well, looking at the y, okay? That the range, for the y equals to sine x, your y is always between -1 and 1. And with this one, guys, remember when you try to actually maybe solve for x, and we just give you, for instance, sine x equals 1.01. As we are working with the functions, your sine x should always be between -1 and 1. And you can check it for yourself in your calculators. If you want to work out x here, okay, shift sign of 1.01. The minute it's slightly above 1, then you'll get an error in your calculators, okay? So your sine x should always be between -1 and 1, and then the one that's not restricted, you've got your y equals to tan x, and your range is from negative infinity to positive infinity, as we looked at that from the previous work. Now, we looked at the effect of multiplying a function by a, right? And then we talked about the vertical stretch or the compression of the function, and the a value is the amplitude of the graph, of the trig graph. Like we said, y equals to 3 sine x, so the amplitude will be your 3. If your a is greater than 1, then the graph is enlarged or stretched vertically, and if your a was less than 1, then the graph is compressed, and the x value remain unchanged. And then we also looked at the effect of adding a q, right? You get a normal graph of y equals to negative 2 sine x. And then now you have y equals to negative 2 sine x plus 5. So what you are doing to the graph is that it was positive sine x. And then now next y equals to positive 2 sine x, and the period changed. And then now it's negative 2, right? Remember? And then plus 5, drag it up 5 units. So if you subtract the 5, you're going down, right? The graph is shifted up if q is greater than 0, and then down if q is less than 0. Okay. Now, we look at the parent functions, of which we spoke about 3 parent functions for now at this level. But your y equals to sine x, which is what we're going to be looking at. Grade 11s, you have to be able to see the shape of the graph. Before you even asked questions, this is a sine graph. Now, with your sine graph, 0, 0, 91, 180, 0, 270, minus 1, and 360, 0, and so forth. Now, the function with parameters. Now, the full parameters for this graph, remember what we did for your revision, the grade 10 revision, is that we moved it up, right? Okay, right. The amplitude changed to 2, to 5, to 3, and whatnot. So it's still the normal graph. Your x are not changing. It's just going up to 2. And then we also moved the graph up by adding the d, which was that. Okay, so we added a d, or we subtracted a d greater than 0 or d less than 0. Moved it up, moved it down. So now we're going to be looking at now what happens if you are moving it, you're sliding it along the x-axis. Who is affecting that in that particular graph? So then the full one is going to be a sine bx minus c plus d, which is what we're going to be talking about in this lesson. All right? And then the other parent function is your y equals to cos x. All right? The a again, which is your amplitude, and then your d, moving it up and down. And then now the full one combined together, we're now going to move left or right. Okay? Now, we looked at your y equals to tan x, which is your parent tangent graph. So the only thing that we looked at in grade 10 was your amplitude. Now, be extra careful with your amplitude of tan, right? So it's not defined. And then you are adding a d, you move it up or you move it down. And one thing that's very important here is that to specify that point, okay? Your negative 45, negative 1, and then 45 and 1 as well, okay? Now, looking at our key concepts for today. Trigonometric functions, you will have your f of x equals to a sine bx minus c plus d. And then your g of x, which is a cosine, a cos bx minus c plus a d. And then your tangent, h of x equals to a tan bracket bx minus c plus a d. Now, what effect does changing the parameters have on the trig functions? Okay. Now, your big A, which is this A, which is right in front of your trig graph. A is the amplitude of the function, the maximum displacement of the graph from rest position. This also provides information about the range of the function. So your range, your A, your y must be between minus A and A, which means that the graph will oscillate within the given range, all right? So now, if for instance, it's from the minimum is minus 1 and then the maximum is 3, then your range, your y is between minus 1 and 3. So it's telling us about your range as well. But A stands for the amplitude of that function, which is the maximum displacement of the graph from the rest position. Now, your B, right, if we look at our B, the small b, the coefficient of x affects the period of the graph. Now we're going to be looking more deeply on the period as well, because most of the problems that we did in grade 10, it was only involving your 1x, like you given y equals to sine 1x. So whereby your period is just 360 there. Okay. Now if your b is greater than 1, the graph is compressed along the x-axis, whereas if b is less than 1, the graph experiences a stretch along the x-axis. Now, since both the cosine and the sine functions are periodic about 360, now remember that the sine and cos graph, they repeat every after 360 degrees. For graphing purposes, the period of the graph for sine and cosine function is given by the period is equal to 360 degrees over b. And the interval will be the period over 4. Okay. All right. Now, if for instance, you given y equals to sine of 3x, right? Now, what do you think the period is going to be here? All right? Well done. We are going to have, this is the b part. This is y equals to sine bx, okay? And then we said, to determine the period, we're going to have the period is your 360, because we know that the normal graph, the mother function of sine x, it's 360, divided by the b is 3. So it means that the period for this graph is 120 degrees. So this graph is going to repeat every after 120 degrees. Now we're saying, however, the period of the tangent function would be given by 180 over b. Now remember that the parent function y equals to tan x. The graph tan x, it repeats itself every after 180 degrees. So to work out, if you now have y equals to maybe tan of 3x, right? So this is your bx, then it's going to be 180 over 3, and then you get your period for that particular graph, which is now 60, and then it's going to repeat every after 60 degrees. Okay. Now, how about the constant c? C, the constant, is responsible for the horizontal translation along the x-axis. By c unit to the right, when c is greater than 0, and to the left when c is less than 0. Okay. All right. Now, the graph is now translated vertically upwards when d is positive and vertically downwards when d is negative. It's still the same thing that we did in grade 10, whereby you're adding a d, you move it up by how many units that it's given there. If it's plus 3, move it up 3 units. If minus 1, take it down 1 unit. Okay. All right. Now, the constant d affects the range of the graph, but the amplitude is going to remain the same. We're going to be looking into that as well. Okay. Now, guys, I am going to give you this graph. You need to draw the graph of y equals to cos bracket x minus 30 for x between 0 and 180 degrees, right? And then we're going to analyze it together. But what I want you to do, during break, you discuss this graph with your mates, okay? And then you draw that particular graph. Just need to check if I have the table. So guys, what you can do for here is you take this graph, work with that graph from the parent function y equals to cos x. And then on the other hand, you confirm with your calculator when like you having your table, and then starting from 0 to 180, and I have given you the interval 30 in between. So we are going to go for break because I can see you are a little bit tired. You need to get some water and whatever you can consume at the present moment. And then we come back and look at this problem together. Okay, let's go for break. Welcome back, grade 11s. I'm sure you guys have been working very hard on this particular problem. Just want to make a very short, quick example here. Let us say I have a graph like this. This is 90, 180, 270, and then 360 degrees, right? This is y, and then you've got a 1 there, a minus 1. We're taking a parent function, y equals to sine x, right? Now this is the graph. Okay? Now, you've got y equals to sine x. Now, if I give you y equals to sine of x minus 90 degrees, all right, where do you think it's shifting? Is it to the left or to the right? Okay, good. If it is minus, so it's moving 90 units to the right. Okay, now your graph should look like this. Ish, my hands are shaking, I'm old. Okay, this is so it's gonna look like that. So it is moved 90 units to the right. Okay, now if it was x plus 90, okay, if this was sine of x plus 90 degrees, all right, we go to your parent function, okay, which is that. And then if it's now 90 units to the left, so your graph should be looking like that. Okay, so we're talking the horizontal shift. If it's minus to the right, and then if it's plus to the left. Okay, now let's look at our problem. Now, we have y equals to cos x minus 30, right? Now, the graph of cos, we know that the normal graph, it's 0 and 1, okay? So we go to 0 and 1. Let's try blue color. 0 and 1. And then 90 and 0. And then 180 and minus 1. Right. So this should look like that. Hey, looks like a straight line. But you'll see it should be curving, guys. Right? Practice that. Yeah. So something like that. It's curving. But now what I want us to look at is you've got x minus 30. Right? Remember what we said? Minus, it's 30 units to the right. So it is the very graph, but I am taking it 30 units to the right. Okay, so in other words, this point, right, at 0 and 0, now it's moved to, no, it's 0 and 1, so it's going to be 30 and 1, all right, and so forth and so forth. Okay, so I hope you've got the very same graph there with you. Now, with this example, you might not have it correct there, but let's just continue and we keep on explaining what is going on with the shifting to the right and to the left. You are given y equals to 2 cos 2x, and then x is an element of negative 180 degrees to 360. What is the amplitude of the graph? Calculate the period of the graph. Sketch the graph within the given domain, and what is the range of that particular graph. Okay, you work with a friend and you give solutions to this. Guys, you have to be very quick. I've got maximum of 3 minutes that I can give you to work on this problem. Right, let's take that 3 minutes. We make sure that we are not distracted. We just go straight to the problem. Let's do this. 3 minutes. Right, well done, guys. You see, you guys are going to make it. There's graphs, and you are doing so well. Let's just check your work, right? We have you given y equals to 2 cos x, all right? And then we asking what is the amplitude of the graph. Okay. Number one, remember that big A that we spoke about? That is that A, the capital letter A. So our amplitude here is 2 for this graph. And then now you need to calculate the period of this graph. Now remember from our note that the period is determined by that B. So this is in a form of cos Bx. So we know that it's going to be 360 divided by B. So 360 divided by 2, you get 180. So this graph is going to repeat every after 180 degrees. Now sketch the graph within the given domain, all right? So you're given from minus 180 to 270. Now we need to just extend it a bit here. That's your 360 degrees. Okay, now guys, your table is going to help you. Now, just want us to recap using a table. You go into your calculator, right? And then you make sure that your calculator is on, and then you go to mode setup. So I'll go to mode setup. And then because I'm working with a table, so I'll go type in 3. The f of x means that I need to put my function in. So the function is 2 cos 2x. 2, and then x should be somewhere, and then close bracket. Right, so we have a function now. Now what you do next, you press your equal sign. The g of x is when you've got two functions. It depends on the calculator that you are using. Because we've got only one, we skip the g of x. Now you're starting. Where do you start? You start from negative 180. So it's negative 180 equals 2. Right? You are stopping. Remember, this is negative 180 to 360. So your endpoint is 360 equals to. Now it's asking you of a step. This step, remember, when you're drawing like your y equals to 2x plus 1 at the interval, it's from 1 to 2, 2 to 3 and whatnot, it is 1. But now you are doing trigonometry, and you've got 45 there. It depends on your grade or what is given to you at that particular juncture. So here, the interval will be 45, okay? Right. Now, if you look at your minus 180 and 2, minus 135 and 0, minus 19, minus 2, minus 45 and 0, and on, okay? Now we need to put these values. I just want to keep them in my head. Minus 180 and 2, and then minus 135 and 0, minus 2 and 0. Okay, so that's 2, 0, minus 2, 0. Okay, and then minus 45, minus 135, minus 90, minus 2, minus 90, doesn't want to go down, minus 45 and 0, 0 and 2, 0, minus 2. Okay, now, see these things. Now this should be a 2, 0, minus 2, 0, 2, 0, minus 2, and then 0 there. Okay. Right? Let's just confirm for the last time. 360. is 2. Oh, okay. Now, for 270 and minus 2, 315 and 0. Let's check at the top 270 and that. And then 225 and 0. Okay, 180 and 2. Okay, so we are fine. Only this part. Okay, and then guys, what you need to do after this is, now you are plotting minus 180 and 2, right? So minus 180 and 2. Okay? Then minus 135 and 0. Minus 90 and minus 2. Goodness. Guys, you know what? Let's do this. The scale is too much. Let's say this is 2. So this goes there. And then that is also minus 2. So minus 90 and minus 2. And then minus 45 and 0. 0 and 2. 45 and 0. 90 and minus 2. Okay. 135 and 0. Somewhere there. And then 180 and 2. 225 and 0. And then 270 and minus 2. And then you'll continue the graph, guys. So now let's look at this graph now. This goes boom, and then turns there, and then you've got your graph. Right, guys, with a period, and then you can continue up to 360, and then we said our period is 180 degrees. So it repeats every after 180 degrees. And then we are asked of the range. The range is minus 2, so your y is between minus 2 and 2. I think you guys have been working consistently. I'm just going to give you a break, and then after the break, we continue with more problems. Let's go for break. Welcome back, welcome back, guys. I'm bringing you, all of you, back together. All right, guys, welcome back, and I can see that you are refreshed. You are pushing. That's what we want. Okay, right, guys. The next problem has got all these parameters together. I'm going to give you a chance first to try it on your own. You're given f of x equals to 2 sine bracket x minus 30 degrees plus 1 from negative 360 to 360. You need to tell us what is the period of this graph. You sketch the graph of f within the given domain, which is negative 360 to 360. And you have to tell us what is the range of this graph. Okay, so you've got 3 minutes to do this problem. Let's continue working. All right, my wonderful grade 11s. Let's look at this function. F of x equals to 2 sine bracket x minus 30 degrees plus 1. At the back of your head, you are checking, starting with the parent function y equals to sine x. Interpreting what is happening to this graph, okay? You've got a normal graph of y equals to sine x. All right? Now, you have your graph. That's your x, and then your y. Okay? Right from minus 360 to 70, minus 180, minus 90, 90, 180, 270, and then your 360. 1 and minus 1. So you've got that normal graph, which is y equals to sine x. Now, moving on. You now bring a 2 in front. That's y equals to 2 sine x. What is happening? Okay, let's just extend it a bit. It's to 2. And then minus 2. Right, guys, it's the same graph, right? Your x stays, but this point is up there. This one is down here. So you've got, this is your graph. This one is here, that, and then that other one. So you've got, oopsie. Right. So we have done that part. Now, you now move on to y equals to 2 sine of x minus 30 degrees. Right. If this is drawn to scale, minus 30 degrees, we agreed that we are shifting it horizontally, but how many units? 30 units to the right. Okay, so now every point you, okay, all right, guys, let's not break this graph. It's the whole graph. Let's see if it's gonna move. Technology bafethu. All right, now let's see if it's going to move. We are moving. Okay, right, fine, guys. So the graph is going to move 30 units to the right, okay? And then from there, you are adding a 1. So you pulling the very same graph that has moved 30 units to the right, 1 unit up. So every point, it's going to now go up to the next one. So this point at 2 will move to 3. All right. Now, you have a picture of what is happening to that graph. Now, let us now go back and draw this graph following all the steps, right? Okay. All right. Let's follow all the steps, guys. I want to take this thing up. Wow. Voila. Zash. Okay. Now, you go to mode, and then it's a normal one. Now, recapping on using your calculator and getting your table right, you go to mode 3. Your f of x is 2 sine of x, which is your alpha x, minus 30 3 0 bracket plus 1 equals to, you are starting, you're looking at your, you're starting from x equals to minus 360 and you're stopping when x is 360. So you start minus 360 degrees. You end at 360. And then if you look in between, it's 0, 90, 180 and whatnot. So our step is 90. Then we've got our table there. At 0, 2,732 and then 2. 0, 2,732 and then 2. Okay. And then moving on, negative 0,732 minus 90, and then the next one would be 0, 2,732. Okay. 0, minus 90, my bad. This one is actually negative 2.732 and then 0 here. Okay. And then at 90, 2.732 to negative 0.732 ish. Okay. At 90, 2.732 to, okay, 2.732 and then 2. So it means that the next one is going to be negative 0.372 and then 0. Yeah. Negative 2.732 and then 0. Okay, guys, now once you have this information, you are now able to take this and then you draw your graph. 0, 2.732, okay? And then this one goes to 2. Let's change this again to 2. And then we ignore that one. And then this is minus 2. Right. Negative 2.732. So it's slightly up. And then the next one is 2. Minus 180. And then 2. And then minus 90. Negative 2.732. Right. Somewhere there. And then 0 and 0. Okay, guys, you'll see your curve should be looking like that, and then you continue the whole graph. But I'm sure you can see the picture. You guys are using a proper scale and you are following this and you're taking it from your calculator straight away, and then you've got your graph. Or you did the very same thing that we've done, interpreting the graph. Yes. So now, coming back here, you're given g of x equals to tan x and h of x equals to tan 2x for x element of minus 360 to 360, right? You need to check, first of all, the period of these graphs, and then you need to sketch these graphs within the domain, all right, which is your negative 360 to 360, and then you look at the range of these graphs. Now, guys, remember, the period is determined by your b. Remember, you've got your tan bx. And then what is your b here? That is 1. And the normal period for tan is 180 degrees. So it's going to repeat itself every after 180 degrees. So the period for G, right, the period for G is 180 degrees. And then we come to H. Now we say the period for H will be Bx, which is your 2x, and that's 180 over 2, which gives us a 90 degrees. Okay, so the next one is going to repeat every after 90 degrees. All right, we will be able to draw the graphs either by using our calculators and so forth. And now with 3, what is the range of the graphs? Right, now remember the range, we're talking of the y values, and you look at your tan graph, something like this, and then should be asymptotic at right, minus 90 and 90. So your graph is something like that, and it continues. But my point is, I'm trying to look at the y values. We're not restricted. Okay, you can start from any negative up to any positive. So your y should be between minus infinity to positive infinity. So in other words, your y is an element of any real numbers. So I hope you guys will be able to sit and do these 2 graphs, but because of time, me and you guys have to part ways for today. Till next time, bye-bye.